Hello everybody. Today we're going to be doing a video on using the TI-84 plus CE calculator, particularly for the AISL, which is the Applications and Interpretation DP exams. I just felt like since this course relies quite heavily on the use of the calculator, I thought I just want to make a video, some calculator hacks that we usually use for the AISL course. So I'm going to go through some of the very common questions where we use the calculator very frequently. So hopefully this video is going to help all those who are taking the AISL course, and hopefully this is going to help you with your revision for the upcoming exams. Okay, alright, so let's get going. We're going to start off with some algebra and functions questions, and obviously there's some very nice little features on the calculator that can get the job done very well. So the first question is basically solving a quadratic equation, right? Something like this, which is 2x squared minus 7x minus 4 equal to 0. There is absolutely no need for you to use either the quadratic formula, or you could factorize the equation. That possibly could work as well, but I just want to show you this video is just primarily using the calculator to solve these questions. Alright, so let's get going. So we have an application on the TI-84 Plus. I'm sure other brands of the TI calculators pretty much have the same feature, but once again, this video is just primarily for the TI-84 users. Okay, so let's go to apps. There is a feature called Polysmith tool, which is option 4. Okay, it could be a different option in your calculator, but just basically go to Polysmith tool. Okay, and this software, this is allowed during the DP exams as well. So we go to Polysmith 2. Now this is obviously a quadratic equation. So we could basically go to the polynomial root finder. We're going to press enter. We're going to choose this to be order 2. We could keep the rest generally to be the same. I think that would be fine. We're going to go on to next, and we just put in the equation, which is 2. I'll press enter. This is minus, I'll put a minus here. Then I'll press enter, then this will be 7. Press enter, this will be minus. Press enter, and finally this will be a 4. Press enter, and you click on solve, and you should get two answers, which is -½ and 4. Okay, so that will be the answer to question 1. I'm just going to put this really quickly for the answer for this. Okay, so just going to copy this. It's going to get x equal to ½ or 4, isn't it? So let's do this, or 4. Okay, so we're going to move on to question 2. And we're going to solve a simultaneous equation with this, and again the TI calculator actually could get the job done. Okay, so just going to show you really quickly how to do this. We're going to go back to main, and we're going to choose the same app again, which is the Polysmith 2, and you will realize that option 2 gives you the option to choose to solve a simultaneous equation. So I'm going to choose option 2. Of course, you could solve as many equations as you want to. You could solve 3 equations to 3 unknowns. This all works out very well. Okay, but since in this case we got 2 equations and 2 unknowns, then we're just going to choose the default option of 2 and 2. Then I'll click next. Then literally you just need to put down the equation here. So it's 3 here. This would be plus, that's fine. So this would be 2. Press enter, this will be 11. Press enter, this will be 4. Enter, put a minus here. Enter, since there's y, so that will be the same as 1y. And finally, this will be 6. I'll press enter. and remember, click on solve. Okay, and you should get the answer to be 23 over 11, 26 over 11. Okay, so let's really quickly just put in the answer here. So x equal to 23 over 11, and y will be 26 over 11. Okay, 26 over 11. Right, I just want to put the answers down. And the next part is question 3. You could find the intersection points of the two functions, which is y equal to x squared plus 2x minus 3 and y equal to 2x minus 1. Okay, now this question is interesting, okay, because there are several ways where you could find the intersection points of the two functions or two equations, and generally I'll show you a few ways to do it, okay. One way is you could basically, right, let's just get out of this first. I think one of the very popular ways where students love to do this is to use the numeric solver. Okay, so they love to go to math, then go to option. If you scroll down, you should see numeric solver. And what they like to do is to put that two equations under equation 1 and under equation 2. Okay, technically nothing wrong with that, but I just want to show you like there are some limitations at times when it comes to the numeric solver. I think particularly when you have several answers to this. Okay, so I'm just going to show you first with the numeric solver, and you will decide for yourself if this works out for you, okay, because there are just certain things you got to watch out for when you use the numeric solver. So you do like x squared, don't get me wrong, still a very good feature to use, x squared plus 2x, then I'll put minus 3, and the other equation would just simply be 2x plus 1. Okay, and we click OK. Then we solve it. Okay, now you're gonna get one of the answers to be 2. Okay, now firstly, there are a few limitations. Now it only gives me one answer, which is x equal to 2. Now, but we do know that when you have a quadratic function and a straight line, you should have two intersection points when the line meets a quadratic graph. So there should possibly be another answer, but that's not reflected under the numeric solver. All it does, it gives you only one value of x, and I think the other problem is it doesn't give you the value of y as well. Okay, so typically I think a graphical approach would work better, but I just want to show you like how would you be able to get another answer for x value. Okay, so I'm just going to show you how we're going to do that. So let's just go back to numeric solver again. Okay, we got these two equations here. Now what you want to do is that you will have to change the boundary for x, because what you are telling the calculator is that you have a specific value of x that you would like to identify what possibly could x be. Okay, because we're trying to obtain the boundaries where you may possibly get the x value, because x could be a positive number, it could be a negative number, it could be a huge number, who knows. So what I would suggest is we could experiment this by maybe putting another number for x. So we're going to try, let's say, a negative number. So I'm going to try, let's say, negative 5. Okay, let's see what really happens when I put negative 5, and I'm going to solve it. Do you realize something? That now it's giving me the negative answer for x, which is negative 2. So there is a bit of trial and error, and there must be an awareness of having the ability to identify that there are two solutions to this question. So I think that's one of the limitations of numeric solver, because some students basically only take the first value that's given as the only answer. So you may lose points for not being able to come up with the two solutions for x. Now, what do I think is a better way to identify the intersection points of the two functions is to plot the graph. Okay, so I'm just going to put in these two equations onto stat plot, and I'll put the two equations here. So I'm going to do x squared plus 2x minus 3. I'll press enter. Then I got 2x plus 1. Okay, and we're going to graph it. So you should see a parabola and you should see a straight line. There we go. Now, do you realize that you get to see that 2 points that intersect in a way? And that's very clear that we got two solutions for this. Okay, so I'm going to show you how to do the intersection with the calculator. So you could go to second trace, choose option 5. Now, they're always going to ask you for the first curve. Okay, now this is one of my preferred ways of doing it. I'm just going to choose a point to the left of the intersection point, which is going to be on the blue curve. Okay, I'll press enter. Now the next one is going to be on the second curve, which is going to be on the red line. I'm just going to move it somewhere to the right of the first intersection point. Okay, then I'll press enter. When they ask you to guess, just press enter again, and it will narrow it down to the first intersection point here, which gives me -2, -3. Okay, we're going to write that down shortly. Then we're going to find the second intersection point. So we do the same thing. We go second trace, choose option 5. When it comes to the first curve, I want you to get really close to the intersection point as well. Okay, press enter. Then I'm going to get you to move somewhere a little to the right, but it's on the red line, and we press enter again. And there we go. You get another intersection point, which is going to be 2 and 5. So this has to be a better way. Okay, it's visually clearer, and this is where you will not make mistakes. Okay, so please make sure if you're using the TI-84 Plus calculator, make sure you know how to use the intersection feature. It is very, very useful. Okay, while the numeric solver has its limitations for this particular question as well. Okay, so let's put down the answers first. We have -2, -3, and the other answer will be 2, 5. Okay, so that will be two intersection points. Alright, so this is the first part, which is algebra and functions. We're going to move on to statistics and regression. Okay, again, a very a big component in a lot of the AI questions. So we got two variables here, which is hours studied and the exam scores. And the question is basically finding the equation of the regression line, predict the score for a student studying 6 hours. So we're going to be using the regression line to make that prediction. Okay, so let's go back to our calculator. Okay, so now in order for us to put in the data onto the calculator, we go on to stat. Okay, choose edit. Right, what you want to put is to put the data under L1 and L2. Okay, so I'm going to put the data in. So it's 2, 4, 5, 7, 9. Then we'll do 56, 68, 74, 85, and 92. Okay, and we press enter here. Now, if you want to find the equation of the regression line, there's a feature on the TI-84 calculator that gets it done. We go to stat, go to calc. Okay, we always choose option 4, which is the linear regression. I know there's another regression for option 8. Just ignore that. Just choose option 4. Okay, so we choose option 4 for this one. If you put the data in L1 and L2, then there isn't anything for you to change in this case. Alright, I'm just going to press enter all the way, and get the equation. So what I really want to do is to find A and to find B. Okay, because A and B is basically the gradient, and B is the y-intercept of the straight line. Okay, And then we're going to put in, and I'm just going to double check one more time if I put in the data correctly. I think that's a very good habit. So it's 256, 468, 574, 785, 9, 92. Okay, this is perfect. Then we go to calc, go back to linear regression, press enter again. Alright, and we're going to put down the answer. So the A is 5.21 and this is 46.9. Okay, 5.21, 46.9. Okay, so I'm going to put y, oops, 5.21x plus 46.9. Okay, and always leave your answer to 3SF. Okay, that's always the degree of accuracy that you need to adhere to in the DPSMs. Okay, and the question says predict the score when a student studies 6 hours. So we're going to use the regression line and we're going to make that prediction, and what you need to do is to substitute 6 into the equation. Okay, so this is basically what you're going to be doing. You're going to take 5.21 multiplied by 6 plus 46.9. Make sure you show this step, okay, because it's going to give you marks as well. This is y. Then we just need to put this onto the calculator. Second, I'll quit this. Then I'll put 5.21 times 6 plus 46.9. Okay, so you're going to get approximately about 78.16. So I'm just going to round it. Approximately. Okay, I'm just going to find the approximation symbol on the Google Doc. There we go. And the answer should just be 78.2. Okay. Again to 3SF. But personally, I think there isn't anything wrong if you were to put that to be 78 as well, since the exam scores were all given in 2 significant digits or to the nearest whole number. But I still like to do everything in 3SF unless the question states otherwise. Okay. Alright, question 5, we're going to be looking at finding the mean, the median, the standard deviation, the interquartile range. The calculator can actually get most of these done. The only thing that they can't find is the interquartile range, because it doesn't give you the specific value for the IQR, but it does give you the upper quartile and the lower quartile. Okay, so we could still work out the interquartile range if we have the upper quartile and lower quartile. So let's just again put all these numbers onto the calculator. Okay, how do we do it? That's the thing. Okay, we're gonna go back to stat. Sorry, this thing always appears, just bear with me for a while. And okay, I'm just gonna delete all these numbers and get these numbers out. Okay, now, so what we're gonna do is I'm gonna put in all the numbers here. So it's 12, 15, 13, 17, 16, 14, 18, 19, 12, and 16. Okay, so what I'm going to go is going to go back to stat again. We're going to go to count. In this case, we're going to choose like one variable stats for this. List, we just put L1 because that's the only number that we put on the spreadsheet. So I'm just going to press enter all the way. Now it's going to give you a bunch of values here. Okay, now the first one, which is X bar, okay, which is basically 15.2, that's the mean. Okay, now if you scroll down and if you want to find the median, okay, that's where you see MED, which is 15.5, that's the median. Now the standard deviation, what we're really interested in, okay, is the sigma x, which is the one below SX. Okay, So basically what I'm really looking at is this number, which is 2.31516738. That's basically the standard deviation that we're looking at. Okay, so we're looking at the population standard deviation, not the sample standard deviation. So we always look at sigma x when we find the standard deviation for our course here, okay, which is a 2.32 in this case, okay. Remember, we don't take 2.44, that's the sample standard deviation, but that's not applicable for the AISL course, okay. Then you may ask, what about the interquartile range? Now, you have Q3, which is the upper quartile. The lower quartile is Q1, which is 13. And all you need to do to find the IQR is to subtract the upper quartile to the lower quartiles, which is 17 minus 13, which gives me 4 in this case. Okay, so I'm just going to put down all the answers here just to consolidate what we have done. So the mean is 15.2, the median was 15.5, standard deviation, I'm going to call it SD for now, I think it was 2.32, let's write that down. And finally we have IQR, which basically would be taking the upper quartile, which is 17 minus 13 equal to 4. Okay, so this should be really easy, and sometimes it does appear in exams as well, so it's marks that you need to grab. Okay, they are that easy for you to achieve as well. Okay, so we're going to look at some questions now that relate to probability distributions. Okay, and we're going to look at a few questions here with normal distribution and some binomial distribution as well. Again, very common questions, and we need to know how to use the calculator as well. Okay, so I'm going to look at question 6 first. Okay, it says that IQ scores are normally distributed. The mean is 100, standard deviation is 15. Find the probability where the IQ is below 120. So this is what I'm trying to find here. IQ less than 120. Okay, this is what I'm trying to find here. Now again, we could use the calculator to get the job done. Alright, so let's quit for this one. Alright. Oh my goodness, this is so annoying. Okay, so let's put this onto the calculator, which you have the mean and the standard deviation, and you're trying to find when the IQ is less than 120. So we're going to go to second, and we're going to go to, sorry, my bad, you just go to vars. It should be second vars, sorry, so I'll repeat my instructions again. You go to second vars. You should see the features of normal PDF and normal CDF. Now in this case, because we are looking at an IQ which is below 120, that means you've got a range of IQs that is going to be less than 120. So in this case, we will choose the cumulative distribution function. So we're going to choose option 2. Okay, now this is where you put in the numbers. Now the lower bound has always been given to you by default. You can just keep it as it is. Okay, negative 1e99 basically means negative 1 times 10 to the power of 99, and that means it's a really small number, okay, which is almost as good as saying negative infinity, okay, in layman terms. But the upper boundary, in this case, we're going to put this to be 120. Oops, 120. The mean is 100, so we just put 100 here. The standard deviation is just 15. Okay, just to point out something, if the variance is given, all right, make sure you take the square root of the variance. That's going to give you the standard deviation. Okay, so make sure you put the standard deviation number correctly in the calculator. Then I'll press enter again, and you should get a probability. In this case, will be 0.909. Okay, so 0.909. So remember, we will use the normal CDF function. Okay, not the PDF. must be the CDF. Alright, now let's look at question 7. A biased coin lands heads 60% of the time. It is tossed 10 times. Find the probability of getting at least 6 heads. Now this question is very obvious. It's a binomial distribution question. Alright, because firstly, you only have 2 outcomes in this case. Alright, either you get tails or heads. Alright, and it's called binomial for a reason, because that's bi means 2, which means that you should have only 2 outcomes. Now you also have the probability of success, where success is defined as being able to get a head, which is basically 60%, and you do it 10 times. Right, so you have each of the toss to be an independent trial on its own, so it kind of satisfies the binomial distribution conditions as well. Okay, now, right, the good thing about the AI course is that you only have normal distribution and binomial distribution. Alright, so if it's not going to be normal distribution, then it should be the binomial distribution, isn't it? Okay, so again, by elimination, you should be able to identify which kind of distribution works for the question. But then again, please make sure you know the conditions that relates to the binomial distribution as well. Now, having said this, okay, we need to know if this is a binomial distribution, and in any of these distribution on the calculator, you always get the feature between PDF and CDF. Okay, so when do we know we use PDF? Is basically when you have a specific number of outcomes that you need in the question. So in this case, you want exactly 6 heads. Okay, so that is a PDF. CDF usually comes with a range of outcomes. Okay, so maybe it could be like more than 6 heads, less than 6 heads. That's going to be using the binomial CDF. Okay, so let's get down to the calculator again. So we're going to do the same thing. We're going to go to second. We're going to go vars again. Then we're going to choose. If you scroll down, you should see binomial PDF in this case. I'll press enter. Now it will ask for the number of trials, which is how many times you perform this experiment, which in this case will be 10, because you toss it 10 times. P is the probability of success, which means what is the probability of you getting a head in this case. So is that 60%? So I'm going to put this to be 0.6. Make sure you put that as a decimal. Okay, now the X value, since we are looking for 6 heads, I'm just going to put 6 here. Then I'll press enter, then I'll press enter, and I'll press enter again. And that should give me the probability very nicely, which is 0.251. There we go. So this will be 0.251. Okay, again, I round this to 3SF. And this is something that you should really get into the habit of doing this as well. Okay, now let's look at question 8. Now 8 was something I wanted to do is because this question is interesting. It says a biased coin has probability of 0.4 of landing heads, toss 8 times, find the probability of getting more than 3 heads. Now more than 3 heads, if you interpret this correctly, what it means is that it's asking for 4 heads or more. Okay, now, but having said this, there is a limitation to the TI-84 calculator, is that when you now, okay, before we even come to that, now I think we can all agree that this is basically using the CDF function. Okay, because we're looking at a range of outcomes, right? 4 heads or more could be 4 heads, 5 heads, 6 heads, all the way up to 8 heads. Okay, so we know that there is a CDF function that we could use. Now, but what I'm trying to say in this case is that there is a limitation to the binomial CDF feature on the TI-84 Plus calculator in particular. It doesn't apply to the Inspire, but this is where the annoying part comes in, and you've got to make sure you know how to use a little rule that will help you to solve questions like this. Okay, now let me just show you what it really does first. Okay, now on the calculator, if we go to second vars, we choose binomial CDF. Okay, that would be option B. Now when you put in the numbers, let's say for binomial CDF, okay, so let's say I put in the numbers first. I'll put 8, I'll put 0.4. okay, and you know that more than 3 heads, it's 4 heads or more. Now, the problem with this is that when it comes to the TI-84, and if you decide to put this as 4, what you are telling the TI-84 calculator to do is basically is asking the calculator to find the probability of getting 4 heads or less. Okay? Exactly. You hear where I'm coming from, right? So you're not really basically finding the probability of getting more than 3 heads, which is 4 heads or more, because binomial CDF doesn't work with the questions where you ask when it's asking for more than a certain number of outcome. It only works for less than. So if it's like less than 3 heads, yes, it will work very well. Okay, so in this case we got a bit of a problem here, because if we want to find 4 heads or more, then we need to do something differently onto the calculator. Okay, we can't just simply put 4 onto this onto the TI-84. So what you need to do first is we need to first find out what is the probability of the coin to have 3 heads or less. Okay, so just hear me out again. I'm just going to write this down. We're going to find the probability of getting 3 heads or less. Okay, because let's put a little asterisk here. TI-84 only works with less than and not more. Okay, because the TI-84 doesn't allow you to put in like boundaries like 4 heads or more, so like the lower boundary to be 4, unlike this normal CDF where you can actually put the lower boundary and the upper boundary, right? But the TI-84 plus CE calculator doesn't give you the option to put the lower boundary and the upper boundary. So, and unfortunately this is something that you just got to work around this. Okay, so so since we need to find 3 heads or less, then what I need to do on the calculator is, instead of putting a 4 here, I'm actually going to put a 3. Okay, now what this does, it gives me the probability of getting 3 heads or less. Okay, so I'll press enter first. So it's going to give me 0.594. Okay, so probability of 3 heads or less is equal to 0.594. Okay, now obviously that's not what the question is asking for. Okay, but it's absolutely fine, because what we're going to be doing is we will be finding the probability of getting 4 heads or more, isn't it? So we're going to use something what we call the complement rule. Okay, now the complement rule is that if we want to find the probability of getting 4 heads or more, now think about this logically. Okay, now if we know that the probability where you get 3 heads or less is 0.594, but we know that the highest probability is always going to be 1, right? So which means the rest of the outcomes, which is going to be 4 heads or more, is just simply taking 1 minus 0.594. Okay, so that's going to give you 0.406 in this case, right? Because 3 heads or less means 3210 head. Okay, so then the next possibility after 3 heads would be 4, right? Because you can't have number of heads to be like decimals or whatsoever. It needs to be a whole number. So that's why we need to subtract 0.594 from 1. Okay, so basically please remember this CDF function that is, and when you get a question which is more than, when the question basically asks for more than, make sure you work around this problem by doing less than first. Okay, that would help you to do this, and then you could use the complementary rule. I'm just going to put this, the complementary rule, where you subtract that from 1 to get the probability of what the question wants. Okay, so this question, very, very popular. If you're using Inspire, no problems at all. In fact, you'll find this problem extremely easy. But if you are using the TI-84 Plus for whatever reasons, make sure you know that there is this limitation that you have to work around this. Okay, all right, so that's question 8. Now I'm just gonna do a bit of geometry work. Okay, I just want to show you a few things. It's not something that is groundbreaking, or is it some insane calculator function that you could use to find the length or the area of the triangle. Actually, it doesn't give you the length and the area that easily, because you still need to be able to visualize how this triangle works, and decide whether you're going to be using things like the sine rule, the cosine rule, and so on. Okay, now okay, let's do this. Now if you draw a triangle here, okay, let's say I draw a triangle here, so let's call this A, let's call this B, oops, okay, and let's call this C. Now if AB is 8, AC is 6, and angle BAC is this angle is basically 40. Okay, now we know that if you have two sides and an included angle, which is basically the angle that is formed by the two sides, we know that in order to find the length of BC, this is where you would use the cosine rule for this. Okay, now so having said this, if you want to use the cosine rule for this, what we need to do is, I'm going to just quickly show you what I'm trying to do here. Now we know the formula for cosine rule in this case. Alright, I'm just going to put out my equation here. Let me make this a bit smaller first, okay? Then I'm going to put the, oops, sorry, that's not the correct function. Let's choose this one. Just a square equal to, okay, just copy this, that could be faster. Oops. Sometimes Google Docs is not great at all. Okay, so B squared plus C, oops, let me just choose this again. Squared minus 2BC, then we put cosine A. Okay, now we know that we're going to be using the cosine rule in this case. Then all we really want to do is we to find out what is BC, isn't it? And to apply this formula, what we want to do is, we know that in this case the small a is basically like your BC. Okay, so we just need to do like a something like this. Now what I want to show you is that when it comes to using the calculator, I need you to work smart as well. Okay, let me just put this equation. Now when you write your steps, this is all required. Okay, you need to make sure you write this step down as well, because if you just simply put everything onto the calculator, and you just somehow make a mistake by putting in the wrong number or whatsoever, then it's going to create a lot of problem, because you're not going to get any marks if you don't show any workings at all. Okay, so it is really important for you to at least put this step down, which is the 8 squared plus 6 squared minus 2 times 8 times 6 cos 40. Now this is what I need you to do. This is where you could actually put all this onto the calculator. Okay, there is no need for you to work for each individual entity in this case. All right, you just need to put this all onto the calculator. Okay, so you've got 8 squared plus 6 squared minus 2 times 8 times 6 times cos 40. Let me press enter here. Okay, so you get 164. That will give you a square. Okay, now if you want to find a, you can just take the square root of it. So if I take this and I copy and paste this, press enter, and that should give you the answer very nicely, which is going to be 12.8. Okay, so what you could do is just put a to be 12.8 in this case. So you can literally just put all this onto the calculator, square root it, and that should give you the answer. What you need to do is just make sure you show this working. The rest, literally just let the calculator do its job. Okay, and the same thing goes for the area of the triangle as well. If you use the formula just to recap again, the area of the triangle is basically half AB sine C. Okay, and all again, you just need to put these numbers into the formula, all right, which obviously looks something like this: half multiplied by 8 multiplied by 6 multiplied by sine 40. Okay, and again, just make sure you show this, and then you put all this onto the calculator to get the answer as well. Okay, this is just I want to show you really quickly is that what you need to put as part of your workings in the exams, and there's no need for you to work out what is sine 40 separately. Just make sure you put all this onto the calculator and get the answer and round it to 3SF. Okay, that should save you a lot of time as well. Okay, now I'm going to move on to question 10 now. Question 10, it says that within the interval 0 to 360, find all the solutions of sine x equal to 0.5. So you got a trigonometric equation, and you want to find the value of x that falls between 0 to 360. So this one is very similar to what we did earlier. We would graph it. Now, before we do that, any trigonometry question, just make sure that when you go to mode, make sure this is always going to be in degree mode. Okay, now I think I may have made a mistake somewhere as well, because I did not change the degree mode when I did my cosine rule. So I'll show you why it makes such a big difference. Okay, let me just copy and paste this, press enter. Now I'll press enter again. Look at that, this is actually 26.45, and if I take a square root of that, press enter, that should give me 5.14. okay, so in fact the answer for this should be 5.14. So it is really important for you to change the calculator mode to degree, okay, because by default it's always going to be radian. Okay, so thankfully I realized this as well, and make sure you don't make the same mistakes, okay, in the exams. Alright, so question 10, once we have changed everything into the degree mode, then we're going to make sure that we plot this graph, okay, which is sine x equal to 0.5. So how do we actually plot this onto the calculator? Okay, so I'll show you how this can be done. So let me just clear this first. Now what I want to do is, when you have sine x at 0.5, what I want you to do is to put y1 to be sine x, which means the left side of the equation, I just want you to put this to be sine x. Now on the y2, I'm going to put the right side of the equation, which is 0.5, so I'll put 0.5 here. Now what you should be expecting is that you should be expecting a sine graph as well as a straight line. Okay, but before we even graph it, okay, because since the interval is between 0 to 360, I need to change my minimum, my x minimum, to be 0, and I'll change my x maximum to 360. Okay, so since x, the domain of x is given, then you should always change the x value as well. The y value, okay, I don't think there is a need to go to -10, because the lowest point on the sine graph is always -1, the highest point is always going to be 1. So we could still try to put -1 and 1 here. Okay, let's graph it and see how the graph looks like first before we decide whether we need to change the window size, but it should generally be quite good. You should see a full wave of the sine graph. There we go, and you have a straight line here. Now it's pretty obvious that the line only cuts the graph at 2 points. Okay, so since it cuts the graph at only 2 points, then it just means that there are only 2 intersection points, which means there are 2 solutions. Now, do you remember how to find that 2 solutions again? To find the intersection point, again, we are doing the same thing. We're going to go to second trace, we're going to go to intersect, then we do the same thing again. So I'll just find the intersection point of the first point. So I'll go somewhere to the left, press enter, just move somewhere to the right, press enter, and you should get 30 and 0.5. That means it's going to be x is 30 degrees and your y value would be 0.5. Okay, so I'm only interested in the x value, which is 30 degrees. Now let's go find out what is the other angle. So I'm going to go to second trace, press intersect again. Again, what I'll do is I'll move somewhere close to that second intersection point, press enter, then I'll move a bit to the right of the intersection point. What this does is basically is narrowing down where the intersection point is, because we got multiple intersection points. Okay, press enter, then you're going to get 150 degrees for this. So in this case, you're going to get two answers for this. So you're going to get x to be 30 or 150. No, sorry, I should put comma 150, because both answers are accepted in this case. Alright, so just something to really watch out for when it comes to trigonometry. Just to summarize, make sure the calculator is in degree mode, because otherwise it's going to distort your results whenever you do any trigonometry that involves sine, cosine, tangent. If you don't change it to degrees, your values are going to be affected. Okay, and of course when you have tedious calculation, just let the calculator do its job. Okay, alright, we're going to look at some calculus questions now, from question 11 to 14. I thought this was something that I find very useful to use the calculator when you find the derivative, finding the definite integral, or even finding the equation of the tangent and drawing the derivative of the graph. This calculator can get the job done for you. It's amazing. Okay, so let's look at question 11. I think 11 and 12 generally will be very easy, something that you're quite familiar with. So it says use your calculator to numerically estimate the derivative of this function at x equal to 2. Now, usually when they ask for the derivative, it's basically asking for the gradient at when the point is x equal to 2 on the graph itself. Okay, so but what the calculator could actually do is to basically to find or estimate the gradient or the derivative of this function. Let me show you how this could be done. Okay, so quit again. There are a few features where you could go. So if you go to math, you see option 8. So this is where you just need to put in the necessary variables into this little function here. So it's d over dx. We always choose x for this. Then we put in the equation, which is x cubed. So I'm going to put like x cubed minus 3x squared. Then I'll put plus 4. Okay, now then I would choose when x is basically 2. Okay, I'll put 2 here, press enter. Now, so in this case, what it does is that it's giving you to be 1e to the power of negative 6. Okay, now 1e to the power of negative 6 is basically 1 times 10 to the power of negative 6. Okay, which is basically very, 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 very close. In fact, it's virtually 0. Okay, because 1 times 10 to the power negative 6 is basically 0.0000001. So that's really close to 0. Okay, so and if you do your derivative for this, okay, I can show you very, very quickly, because we obviously can do this algebraically as well. Let me just grab the pen feature. Here we go. Now, so we know that when you differentiate this, so it's f prime x in this case. So when I differentiate this function, what it does is that you do like something like 3x squared, okay, minus 6x. And your job is basically put the 2 into this derivative function in this case. And if you put 2 into this, you're going to get like 3 times 2 squared minus 6 times 2. So what you're actually going to get is basically 12 minus 12. Okay, equal to 0. That's when x is basically 2. Okay, now, but what the calculator shows you is basically 1e to the power negative 6. It doesn't really put like 0, but generally when you put this, if you're going to use the calculator to do it and you see things like 1e minus 6, which is the same thing as 1 times 10 to the power negative 6, that is basically essentially 0. So you could basically confidently write the derivative or the gradient to be 0 in this case. Okay, so hopefully this clears up everything as well. Now, question 12, it says that you're supposed to find the definite integral, okay, of this. So you can actually produce this onto your calculator very easily. Okay, so we're gonna go to math again, which is option 9, which is the integral of the function. So we choose option 9 here. So I'm just going to put the upper boundary to be 3, lower boundary to be 1. Then we just type in the function here. So it's 2x squared minus 5x plus 3. Then we make sure you put dx here. Then press enter. Okay, which is basically 3.33. What this basically does is that it's giving us the area under the area between this graph and the x-axis in the with the boundaries of x to be 1 and x equal to 3. Okay, so that's what 3.33 actually really represent in this case. Okay. So hopefully this makes some sense to you. Okay, then we're going to move on to question 13, which is find the equation of the tangent of function x equal to x cubed minus 3x squared plus 4. Okay, now, so basically we know that when you have a function, you can always draw a tangent at a particular point on the graph. Now, what the calculator does is that it can actually draw the tangent for you, and at the same time it can also help you to find the equation of the tangent, which means that you may not even have to resort to using an algebraic approach to find the equation of the tangent. Now, by having said this, in most of the questions that I've seen, usually what the question is always seeking for is finding the equation of the normal, okay, which is basically the perpendicular line to the tangent. So make sure you know how to find the equation of a normal using an algebraic approach. Okay, if you need help, just let me know. Write in the comment section, say that, hey, could you do me a video on that? I'm happy to do so. Okay, so so let's use the calculator to get this done. I'll show you. This is a very interesting way to do this. So first thing you need to do is to make sure you graph this equation first. Okay, so I'm gonna put okay, x cubed minus 3x, oops, sorry, should delete this first. So it's minus 3x squared, then I have plus 4. Okay, so what I'll do is I'm gonna graph it. What I'm going to do is I'm going to change the window size. If you don't see any graph in it, you might want to click on zoom. You could choose option 6 first, which is zoom standard. Okay, perfect. So we get to see the cubic graph here. Now, what you could do is if you want to draw a tangent, this is where you need to do. Okay, so I'm going to go click on second, click on this program. So second program, which you get to see the word draw here. Now you see option 5, which is tangent, so I'm going to choose option 5 here. Now it's going to ask you where are you intending to draw the tangent. So all you need to tell the calculator is that since we're looking at x equal to 1, so I'm just going to click 1 on the calculator. I'll just press 1 here, press enter. and you will see the tangent that's going to be drawn on the calculator, and it's going to give you the equation of the tangent as well, which is here, which is y equal to negative 0.2999999x plus 4.99999 again. Now again, if you encounter a situation like this, you can just simply round up to 2.99999 to the nearest whole number, which is going to be negative 3, while the 4.99999, if you round this up, it's going to give you 5. Okay, and I can guarantee if you try to work this from an algebraic approach, you should get the same answer as well. Okay, so I'm going to write this really quickly. Equation of tangent is basically y equal to negative 3x plus 5. Okay, but I will still encourage you to be able to solve this from an algebraic way, which means that you differentiate the function, substitute x equal to 1 into it, then do y equal to mx plus c, which is basically finding the equation of a line. Make sure you know how to do that as well. Okay, but again, this video is just to show you the calculator hacks of being able to draw a tangent on your GDC. Okay, now next question, we're going to look at how are we going to draw the derivative when you are given the original function. The calculator can actually get the job done as well. Okay, so what the question is basically asking is, can you draw me the gradient function of the original graph? Okay, so let me show you how this is done. So I go back to stat plot. Now under y2, okay, because it's the same equation that I use, under y2, what you want to do is you go to math. I'm going to choose option 8. Now what I'm going to do is I'm going to put d over dx, and I'm going to put the equation, which is y1. Now one way is you can just type in the equation of x cubed minus 3x squared plus 4, but I think it's too much work. What I'll do is I'm going to go to vars, and I'm going to choose y vars. In this case, I'm going to choose option 1. I'm going to choose y1 in this case is because I have put in y1 as x cubed minus 3x squared plus 4. So rather than retyping the whole x cubed minus 3x squared plus 4, I'm just going to put y1 over there and let the calculator know that, hey, I want to find the derivative of y1, which is the original function. So I can just simply put y1 onto this. And finally, the next part of it would be, I just need to put x to be equal to x. Okay, because your derivative function should be with respect to x as well. Okay, then what I'm going to do is just graph it. There we go. So the red one is basically the derivative function. Okay, and this is how you basically draw the derivative of the graph, alright, which is the red one. So again, if the question asks you to sketch the derivative, all you need to do is just draw the red graph. That's it. Easy, right? Okay, so please make sure you know how to do this little bit, because that's going to help you to be able to find the derivative, and it works for all cases. Okay, so if you want to draw the second derivative, you could also do something very similar to this, where y1 is just going to be the derivative function, then y2 is just going to be the derivative of the derivative. You see what I'm coming? That's the second derivative, right? But anyway, you get the point on how you could draw the derivative of the graph. All right, okay, finally, last two questions. All right, we're going to look at financial maths now. Again, another very big component in the exams. You need to know how to put this onto the calculator. Now usually what I like to do is basically you should always be writing this on your calculator, because you need to understand how this basically works before you put all the numbers onto the calculator as well. Okay, oh sorry, it should be NI, then we should have PV. Now I'm going to explain what all this means shortly. FV, I think it's PMT comes first, then it will be FV, then you have PY and CY. Now this is what you should also be putting as part of your workings as well, okay, because you get points if you put in the correct numbers. Even if you get some of the numbers wrong, you